So good morning again. So in today's class, we will be looking at multiple ideas, and you should pay attention. And if you have any questions, you should ask. The first set of ideas that we will see is related to what is called as a scope and lifetime. Okay, this is the first set of ideas that we will be seeing. So let's write a small code. Um, Wherein you read two variables. Let's say there are two variables, A and B. A is equal to 10 and B is equal to 20. And then you have some function which computes the average of these two variables, right? So it's the average of two variables, let's say. So you have uh, float, mean. Actually, let's say it takes two uh, yeah, float v1 comma float v2, right? Let's make these variables also into float. So the variables a and b are of type float, and yeah, return statement in the main function. Avg is equal to mean a comma b. All right. So this is the program. Let's compile this program and see what it gives. So GCC mean.c. So it's successfully compiled, and it says mean of 10 and 20 is 15. So here, few important ideas here is, if you consider the variables a and b, uh, these variables a and b, they can be used only within the function main. So these are called as local variables, the variables a, b, average, avg. So there are three variables you can see here, a, b, and average. For these three variables, their scope is within the function main. And if you see the function mean, the scope of the variable average is within the function mean, within this function. Similarly, the scope of the parameters v1 and v2 is within this function. So if we try to, like for example, so here in the function in the function main, if we try to access the variables v1 and v2 or average, it's not going to work. Like for example, let's say you have something like this. You want to use float average. So you can see average is a variable declared in this program, but it is declared within function main. So because of that, we can use it only within main. And you can see on line number 17, when we used average, you can see that there is a compiler error which says that identifier average is undefined. Are you all with me here on this? Yes, no? So the second idea, so scope is a very, very important idea. The second idea is, let's say, uh, you have something like a float sum square. You want to compute a square plus b square. So sum square is equal to a star a plus b star b, and so sum square of right. So here in this case, the scope of the variable sum square is from line number 20 onwards. We can use the variable sum square, but we cannot use it from line number 14 to line number 19. So the scope of the variable sum square is restricted to the function main. It is restricted not only to the function main, it is we can use it only after its declaration on line number 20. So if we run this program, so I think I should let me keep it like this. I will bcc mean.c. You can see it says sum square of 10 and 20 is 500. So this is the second important idea. Actually, in C89, you are not allowed to declare variables in the middle of a function. All variable declarations, they should come at the beginning of the function. So like in C89, this declaration on line number 20, I think it is not allowed. So let's try to see, compile it using C89 and see if this is the case. It's still working. Okay. So in one version of the C, I don't know which version of C it is. That is the version in which I learned programming. So in that version, it is not, you are not, or maybe it is ANSI. Let's see. I think ANSI means C89, I guess. Okay, anyway, don't worry about it. No, it's not like that, Siddiq. So when I learned C programming long time back, you are not allowed to declare variables in the middle of the function, in the middle of the function. I don't know in which version of C it is. And then, so Yeah, I think it is C89, but it is not complaining here. So that's the reason I'm bit at a loss. It's okay. Don't worry about it. It's not important. So all you have to, yeah, it works. It works. Not a problem. Yeah. And then yesterday, um, there is one interesting question. Maybe so. Let's say if we have a loop for uh, I equal to 0, I less than 10 plus I, and then you say printf uh, no, uh, percent d times percent d equal to percent d. So you are just printing. So here you can see the variable I, it says it's not defined. So we can define the variable I here, somewhere here, and then this goes away. And then let's compile and see what happens. Oh, I should use slash n. All right. So this program, if you see on line number 27, we are using variable I. So we can have the scope of the variable I is the whole of the function main, but you can see that we are using variable I only in the loop, for loop on line number 27 to 29. So in order for us to kind of write bug-free programs, we can restrict the scope of variables which are confined to some section of the program. So what we can do is, if I keep int I here, then what happens is, the on line number 27, the variable I in the for loop, it is restricted only to uh, it is restricted only to that for loop. So now if you see at the after this loop, if we try to use the variable I, if you write something like your, you can see that the variable I is now declared, it is set as undefined, because I is the scope of the variable I is within that for loop, is within that block state. Right? So let's say if you are trying to compute sum of squared of numbers, then maybe you can have something like int sum is equal to 0, and you can have sum is equal to sum plus I star I. Then and then if you try to use sum again here, sum is not defined, because sum is yeah, so the sum is declared within for loop, so its scope is within the for loop, so it is not visible outside the for loop. So it's the scope of the variable sum is within that for loop. Are you all with me here? All right. If you compile it, you'll get an, you'll see undeclared value of vi is undeclared. All right. So now let's do one thing. So don't worry about the lifetime for the time being. We will talk about, but let's say if I have something like int I is equal to 5 on line number 26, you can see, and then sum is equal to some arbitrary value, some 10. So now when you compile, what will be the, let's do one thing. So when I run this program, what will be the value of, what will be the values of I and sum that gets printed? Yes. So here you can see this I that you are seeing on line 26, it is masked by a different version of I which is declared in the for loop 27. Similarly, the sum that we have declared on initialized on line number 26, it is masked by the sum that is present in this for loop. One more thing, so when we run these programs, and you will see the value of so the value of I and sum will be equal to 5 110. What should not be undefined? I didn't get your question, Siddiq. We we declared it above loop, no? I is used at different places. The I that you use within that for loop. So if you see the I, so this I, let's call it as this is LOI, this is LOI, this is LOI. So in this loop, we are all referring to this LOI. And then you have the red eye here. So the I here, it refers to the red eye. Similarly, the sum here, it refers to the red sum. Are you all with me here? All right. Yeah, so for loop is a block statement. So when you have I and sum that we declare here, compiler has a way of figuring that out. So you'll study in the compiler's course, but it's not too difficult to do it. Because when the compiler enters, processes the for loop, it encounters a different declaration of I. So until we come out of the for loop, it tries to use this I only. Yeah, they will have different addresses. These two different variables, they can have two different addresses. The I within the for loop and the I on line number 26, they will have different addresses. All right. One question, we cannot use the red eye in the for loop. It's not possible. Good question, Sohit. Yeah. There is no way for us to use the red eye in the for loop. In fact, I have a use case here. After we come out of the for loop, the yellow sum, there is an yellow sum here, right? The value that we have accumulated in it, it is getting lost. So this yellow sum in this, it is getting lost. But I want to use this sum outside this for loop, but I don't have a way of doing it. In fact, I want to find a way of saying assign yellow sum to red sum. But unfortunately, in C, it is not possible. It's not possible to use this. What is this? I didn't get it. What is your question, Siddiq? There is no specific name for it. No, this is generally, these are all come under what are called as scope rules. Scope rules of a program. Yeah, that's true. So what I said is true. So this particular way of computing sum is not good because you are not able to access sum outside. So the way to fix it is like this: you declare sum outside, so that it is possible for us to use sum after that also. That's true, it is possible. Balram has a good point that we can use the pointer variable containing the address of red eye inside the loop. It's perfectly possible. All right, so we have some good set of questions and good set of suggestions. Uh, so now, uh, the next important idea is the idea of global variable. So let's now try to change this thing. So I want to use, right? So I am changing the way this whole code is, no, the function mean does things. So when you declare a variable outside any of the functions, then it becomes what is called as a global variable. So on line number 3, we have declared what is called as a global variable average. So the scope of a global variable is the whole file. You can use the variable average in the complete file. So the function mean can access the global variable average. The function main can access the global variable average, so on and so forth. So now what we did is we made the return type of the function mean to be void, and on line number 18, now you can see that there is an error because mean is supposed, it doesn't return anything, but you are assigning it to a variable avg. So the compiler is complaining. Okay, the compiler is complaining. You can see that. Oh, okay. So there is an interesting thing here. So the local variable, so I mistakenly, so the local variable, there is a local variable average and there is a global variable average. So when we do the assignment, you know that the local variable, this will be to the local variable, but not to the global variable. So anyway, let's see. Our thing is we just call mean, and after we call mean, we are thinking that the average will be present, that the average of these two numbers will be present in the global variable average. That is our expectation. So anyway, let's comment this out. So now what happens is when we call mean on line number 9, we are computing the average and assigning it to the global variable average. So when we are back from the mean, we know that the mean of A and B is present in that variable average. So you just print it. So let's compile this. See what happens. So you have I is equal to 5, sum is equal to 285. Yeah. So you can still see the mean is computed properly, right? Are you all with me here? This particular approach, we are taking how mean, the function mean has void type, but still we are main and mean are able to communicate through a global variable average. The function mean and the function main, they are communicating to a global variable average. If we uncomment the code on line number 7, and if we compile and run, what will be the output of the program? If I run the program, this is the code, what will be the output of the program? Garbage value is one answer. Any other answers? Undefined is yet another answer. We commented, we removed the comment on line number 7, we have removed, Yash. Any other answers? Zero. So Balaram Krishna changed his mind from garbage to 0. So let's see what happens. Garbage. You can see the value is 0. It's not garbage. So the reason is all global variables, they are by default initialized to 0. Yes. So here on line number 18, when main is referring to average, this average is, let's say if we call it as, this is red. So this is red. So this is yellow. And when we are assigning this thing, this is to the yellow average, not to the red average. You're all with me here so far? So these are the important ideas about scope of variables. Are you all with me? Yes, no? Can I get an S from all the students who understood, so that we can go to the next idea? Thank you. So this is an online mode, so I cannot see your faces and get a feel for whether you understood or not. So that's the reason. Great. So now let's move to the lifetime of a variable. So yeah, let's kind of take this program. Yeah, so let's use. Okay. Right. So let's write one more thing. Float SumSquare. I'll just use temp. All right. So here is a kind of bit confusing program. Does this make sense? I'm just don't get confused. Just wait. I was just trying to see if something. Yeah, I had something in mind, so I just explored. So it's not. Yeah. So all right. Are you all with me in this program now? So we wrote another form function SumSquare which computes sum of squares of two input variables and then returns it back. So let's compile this program and see if it works. Yeah, so it kind of works. There is no problem in it. So here I want to point out to few things. So if you consider the global variable average, the lifetime, so now we are moving from the concept of scope to lifetime. The lifetime of the global variable average is the whole program execution time. The lifetime of the variable, so if you look at the lifetime of this variable, so the lifetime of this variable average, it is whole program execution time. It is whole program execution. That is the moment when you say, the moment you give the program for execution dot slash a dot out, the memory for the variable average will be created and it will be there throughout the whole program execution. Are you with me? Whether the program, whether currently the program is executing function main or some square or mean, it doesn't matter. What happens is the function, the memory for the variable average will be allocated throughout. But on the contrary, if you see the variable temp here, the in some square, its lifetime will be its lifetime. So its lifetime will be only when the function sum square is active. Only when the function sum square is active. So that means you can see function main, it calls function sum square sometime. Only when the function sum square gets called, then only the memory for the variable temp will be allocated. And after the function sum square gets execution finishes, then the memory allocated for temp will be released and there its lifetime ends. Are you all with me here? And so the global variables whose lifetime is whole program execution time, they are stored, they are stored in what is called as a global data segment. There is what is called as a global data segment in which, don't bring in heap now, we will talk about heap in the next class. So there is what is called as a global data segment in which the memory for global variables is allocated and the memory for local variables is allocated on the stack. So they will be allocated memory stored on the stack. How many of you remember the discussion on activation records and stuff? Activation record, does it ring any bell? So anyways, so the memory for uh, local variables is allocated on what is called as a program stack. And so initially there is the program stack for consists of the so there is what is called as an activation record for a function. So when we are in function main, the activation record for function main will be present on this stack. This is what is called as a program stack. And then when you call SumSquare, what happens is the activation record for SumSquare gets pushed onto the stack. So this is the activation record. Yes, yes. This is the same stack that you see while debugging. So this is the activation record for SumSquare, and this is the activation record for main. And the memory for the variable temp, it will be allocated on the activation. There will be some other information also, but what happens is, yeah, this is the activation record for main, and this is the activation record for temp for the SumSquare. And within that activation record contains many other details, many other information. So among those, one thing it contains is the memory, that is the memory for the local variables. So after you are out of SumSquare, so main calls SumSquare, and then the activation record for SumSquare gets pushed onto the stack. And after we are out from the SumSquare, the memory for no, the activation record gets popped out, and the memory that is allocated to the variable temp gets lost, and the lifetime of the variable temp also ends. Are you all with me here? So in general, if I would like, I want to recall this picture, that this is your whole program. This is your whole program. This is program memory layout of in-memory layout of a program, in-memory layout for a program. So in this layout, a part of the memory is allocated to the operating system's kernel, and the part of it is allocated to the BIOS routines. And then a part of it contain is what is called as a there are some parts which I'm ignoring for the sake of simplicity. So there is one part called as a data segment. In the data segment or data section, here the memory for all global variables will be allocated. Global variables reside here. And then there is a part called as a code section, in which the instructions of your program are present. This is called as a code section. And then you have what is called as a stack. This is your program stack. And this stack grows in this direction, program stack. So whenever you call a function, what happens is an activity, the stack grows, and and the activation record associated with that function will be pushed onto the stack, and the memory for the local variables, etc., will be allocated there. And then in the next class, we will see, you have already studied this, and we have what is called as a heap memory. Whenever you make a call to malloc, so malloc, when you allocate memory using malloc or calloc or realloc, all these things, they allocate memory from this chunk called as heap memory. So let's see. Let me. Yeah. We have seen quite a, what is the chunk? I didn't get you. Oh, okay. Yeah. So I want you to pay attention here. This is what is called as a call stack. Uh, I will, in order to clear up the mess here, I'm just let me. So right now I kept a breakpoint on line number 26. So the program stopped execution on line number 26. So if you see the call stack, the program stack, it contains the activation record associated with function main, because that is the only one which is active. And if you see in function main, there are local variables a, b, different things, SumSquare, I, and all these things. There are different local variables present in the function main. And the memory for these local variables is allocated on the call stack associated on the activation record associated with the main. And this is the state of the call stack. The call stack contains only the activation record for main right now. And then if you step into this, so now function main is calling main. Now if you see the call stack has the activation record for main, and followed by the activation record for the mean, and in the activation record it has memory for the local variables v1 and v2, and average is not a local variable, it is a global variable. So because of that, it is allocated memory and some other place. That is the data section. Are you with me here? Does this make sense? Yes, no? And then, so now let's go. You print this, and then you. So now you can see that main has called SumSquare, and SumSquare has three variables, v1, v2, and temp. These are local variables. The memory for all these three is allocated in the activation record associated with SumSquare. Okay, so you execute, you come out. Yeah. So on and so forth. So now let's try to do one more interesting thing. Um, I am writing a function called as int acc sum. Uh, yeah, let's use right. So here uh, I use a variable static int counter equal to 0. So if you see the variable on line number 22, there is a variable called as counter on line number 22, and it is initialized to 0. But the difference is there is a keyword called as static attached to it. There is a keyword called as static attached to it. So what happens is when we attach, if you consider the variable temp versus the variable counter, uh, uh, so the lifetime of the variable temp ends as soon as the function SumSquare is returned, but the lifetime of the counter will be the whole program execution time. The lifetime of the variable counter, this is whole program execution time. That is, the value of the counter, it will be preserved across function calls. Like when you call count for the first time, the value of the counter is equal to 0, it gets incremented by 1. And when you call count for the second time, so what happens is the value of the previous value of the counter will be restored, will be present, and it gets incremented, it becomes equal to 2. So let's try to see how this thing works out. And let's try to call this function count somewhere. Yeah, so let's say, yeah, for the sake of, for, yeah, why not? I'm just calling count. So when you call count for the first time, yeah, so there is a very good question from Mukund. What is the difference between global and a, yeah, let's compile this code. You can see that the value of counter gets preserved across function calls. The value of the variable counter. So in order for the value of the counter to be able to be preserved across function calls, where should counter be stored? Should it be stored in the data section, or it should be stored in the stack? Yeah, so it should be stored in the data section, because if it is stored in the stack, as soon as we are out of the count function, its value gets lost. Its value gets lost. So let's try to keep a breakpoint here. So yeah, so the point here is, so there are two questions here. If you look at the variable counter, its lifetime is the whole program execution time, but its scope is within the function count. You cannot use the variable counter in any other function. You can use counter only within count, except for the fact that the lifetime of the variable counter is throughout the program execution time. And because of that, we would like to store it in the data section, but not on the activation record associated with count. So if we compare the variable temp and counter, what is the scope for the variable temp and counter? They are the same. That is, they are restricted to the functions in which they are declared. Yes or no? The scope for the variable temp and counter, the scope for variable temp and counter, they, their scope rules are similar. That is, they are available, they can be accessed only in the function in which they are declared. Are you with me on this one? The scope for temp versus scope for counter. How about the lifetime of temp versus lifetime of counter? How do you compare the lifetime of temp versus lifetime of counter? So temp is alive only when the function SumSquare is active, whereas count is alive even when the function count is not active. It is the whole program execution time. So Siddiq, a different way to put it is counter is alive throughout, but it can be accessed only when count is called, only when count is invoked, because its scope is within count. Yeah, counter's lifetime is throughout the program. Yeah. The value of count is not lost. The value of counter is not lost. And between, so here I gave a contrived example for static in counter. Can you give me an interesting use case for a static local variable? This is what is called as a static local variable. Do you have an interesting use case for static local variable? Can you give me an interesting use case? Return arrays. We can never return arrays. No? Can you give an interesting use case for static local variables? Any program which where you think this could be useful? So one use case, of course, is we will know how many times a function is called. So sometimes we need to know that, like how many times. No, recursion is not a great. We can use it to calculate time complexity. Okay, profiling as they call it. No, Sanyam. So static variable, it is only when you call a function for the first time, then only it gets initialized. Subsequently, the initialized value will be used. Line number 22, it only tells the compiler that, counter is a static local variable and it should take the initial value 0. That's all. So when things are set up, the counter will be equal to 0. It's not the case that every time you call count, counter is set equal to 0. You have to initialize to something. Right now, you initialize it to 0. Counter is equal to 0 right now. But you don't need to initialize. So it depending upon some logic, you can initialize it to something. Yeah, static is initialized only once. Yeah. I'm not sure if static's default value is equal to 0, but you can check. Can we use it for different objects instructor? I didn't think of such complex use cases, Lavisha. Good question, though. Yeah, if you write static int counter and counter is equal to 0, this is not good. Then every time you enter, counter will be equal to 0. This doesn't serve any purpose. All right. So this is about scope and lifetime of variables. And so there are a couple of things that I want to discuss. Maybe in one of the subsequent classes, I would like to discuss. So how the scope and lifetime. So right now, all the programs that you have written, they are in a single file. Okay. So when we do multi-file programming, so multi-file programs, that is, your code base is so large that if you are writing, let's say 10,000 lines of code, then no, the code is spread in different files and different people will be working on different parts of the program. Then what happens is, so in multi-file programs, how scope and lifetime are defined. So this is one important idea. So we'll see in a later class. And then, so in the same context, There are what are called as make files, and we will see how to write these make files. Maybe I will cover these things in the last lecture of this course, but in the next three lectures in the next week, we will talk about dynamic memory. We will revisit pointers and we will look at dynamic memory. So that's all I have for you today. And